Now we're going to learn how to take a derivative of a function. Actually, we already did, but I just never labeled it out for you. So, the derivative is simply the slope function that we learned before. So, we read this as f prime of x. And this f prime of x is the way we write the derivative of x. And so this process is called differentiation. And this is the derivative of f. Okay, so there are several ways that we can write the derivative notation. There we go. I wonder if I didn't look right. So the derivative of f. So there are several ways that we can write this notation. So one way is f prime of x. Another way is y prime of x. So sometimes instead of writing f of x equals something equation, you write y equals something. Right? So if we're using the y notation, then we can write y prime of x. And the last notation is kind of weird, dy over dx. And this means that we're taking the derivative of y with respect to x. I won't go into depth as to what this thing means until we get to implicit differentiation. For now, just know that this is another way to write the process of taking a derivative. Actually, if you want, you know what? I'll tell you. So dy over dx. So this d means it's a differential. It's going to be a very small amount. So the d means it's going to be a very small amount. So in a sense, we're taking dy and dx, or delta y over delta x, but we're letting the deltas be really small. So this notation is telling us to do this. It's telling us to find the limit of delta y over delta x as delta x approaches 0. And you saw that this thing is delta y over delta x is equal to this. Right? And this thing is equal to differentiation. Right? So that's why this notation is the same as this. Because dy over dx is telling us to find delta y over delta x, but we're going to let delta x become extremely small. So we're finding very small intervals, and which is the same thing as taking derivative. If you didn't follow this part, that's okay, but it's something that you will have to understand later. Probably not right now, though. Right, so if f prime of c exists, we say that the function is differentiable at the point c. Okay, and if the function is differentiable at every point within the interval a, b, then we say that the function is differentiable on the point on the open interval a, b. There's some formal terminology here. Okay, so if this thing comes out to be a number, then that means that the function is defined at the point c. So let's do an example. Say we're given this function 3 times x squared minus 4x plus 5. And directions say find the derivative of f of x. So find f prime of x. So we first use the limit notation. Let me write that out again for us. Okay, so that's that. So we're going to use this notation here. And then this is basically the same thing I did in the last lesson, in the last example. We're going to leave the x's alone. We're not going to plug anything into them. We're just simply going to replace f with the function here, with the actual function. Alright, so plug in we're going to plug in x plus delta x. So 3 times x plus delta x squared minus 4 times x plus delta x plus 5. Minus, now we're going to minus the actual function, right? So we're going to minus 3x squared minus 4x plus 5 all over delta x. Now we're going to expand everything and distribute everything out. So 3 times x squared, okay, so it's going to be plus 2 times x times delta x. Okay, but we have 3 out here, so it's going to be 6 times x times delta x plus delta x squared times 3. So 3 times delta x squared minus 4x plus 4 delta x plus 5. Now there's a tricky part here. Notice that we're minusing f of x. Here I forgot to add the parentheses. It's very important that you do not forget to do that. That's a common mistake. So distribute the negative sign. All divided by delta x. Okay, I guess the fun part. Get to cancel. Right. So plus 5 minus 5, that cancels away. Minus 4x plus 4x, that cancels away. Okay. 3x squared minus 3x squared, that cancels away. Now notice that the terms that remain all have delta x in them. Okay. That's always going to be true. So if something doesn't cancel out, that means that you might have distributed wrong or expanded wrong. So what we have left is 6x plus 3 delta x squared plus 4 delta x all over delta x. So this is going to cancel. The squared sign is going to cancel, and this can cancel. So what we have left is 6x plus 3 times delta x plus 4. Alright, so as delta x approaches 0, this term is going to approach 0, so what remains is 6x plus 4. So 6x plus 4 is the derivative of the equation, of this equation here. So 6x plus 4. Now, what does 6x plus 4 give us? I don't think I told you this yet, but the derivative tells us the slope of the curve. Right, so the derivative is going to tell us the slope of the tangent line to the curve at every point. So it's going to give us the slope of the curve at any point. And let me find, here it is. Okay. So this is the original function, 3x squared minus 4x plus 5. And on the bottom here is its derivative. So this is going to be our f of x. And our x prime of x is equal to 6x minus 4. Now we're going to pause and take a look at what this exactly means. Okay. This is the derivative of this. And this is going to give us the slope of the curve. And by the slope of the curve, I mean the slope of the tangent line that touches the curve at a certain point. So let's pick a random point. So let's take a look at this point here. Okay. At this point here, the tangent line is going to look something like this, right? So it's going to be pretty steep, and so the slope of this tangent line is negative. It's very steep actually. So it's going to be a large negative number, and this is a x-axis and this is a y-axis here. So you can see over here that it is a large negative number. So the slope of the curve is a large negative number. Alright, let's choose another point here. Okay, this point is still negative, right? Sorry, the slope here is still negative. Let's draw in a tangent line. The slope here is still negative, but is it as steep? No, right? Because originally it was this steep. Now it's this steep. Okay, so because it's not as steep now, but it's still negative, we expect a smaller negative number. Draw it down here. Yes, it is. It's a smaller negative number at this point. Right. Okay. So these axes match up. Now let's take a look over here. Over here is the vertex about. So if we draw a tangent line there, it's straight. Okay. So a tangent line here is straight. That means that the slope of the curve at this point is 0. Let me take a look. Yes, this is our derivative, and the derivative at that point is equal to 0, because the derivative tells us the slope of the curve, and the slope of the curve is 0 at this point. Right. So let's choose another point here. We choose this point. So it's positive, right? So we see that the slope is upward. It has a positive slope. And it's not that big, it's 0, right? So we take a look down here and we see that, yes it is, the derivative is positive and it's not a huge number. If we choose this point here, we see that the slope is much bigger. And so this is the slope here, and here we see that the slope is much bigger. And therefore we expect a larger number here. We expect a larger positive derivative because the slope is bigger, and yes we do. And so I just walked you through interpreting these two graphs. So as you can see, the slope is initially large and negative. It's steep, so it's large, and it's pointing down, so it's negative. So the derivative is large and negative. Move in is still pointing down, so this derivative is still negative, but it's not as steep. So the derivative is smaller. Over here, the slope becomes 0. And derivative approaches 0, and here it's actually 0. And when the derivative is 0, that means that the slope is 0, so that means that it's horizontal. The tangent line is a horizontal line. And as we increase here, right, it's pointing up now, so we have a positive number for the derivative. And as we move up even further, the tangent line, or the curve, becomes even steeper. Therefore, the derivative increases in value. Alright, that's that. See you next lesson.